Welcome back to Artworks Garage, everyone. Let me elaborate a little bit for you today on what it is that I'm doing. Simply, I'm building a big brake kit for my 1988 Ford Mustang GT. Now, I wanted a more capable big brake kit because I'm increasing power. Who doesn't add more power to their Foxbody Mustang? I'm going to be using a crate blueprint engine that will put out approximately 360 to 400 horsepower. That's nearly double what this car came with stock, and so it needs bigger brakes. What I chose to do was go with 2014 Cadillac ATS front brake calipers. It's a four-piston Brembo, and it's gorgeous, not to mention it's been done before. I'm using rotors from 2004 Mustang Cobra in both the front and the rear. And it's worth noting that I'm using SN95 spindles in the front and SN95 axles in the rear. So I wanted a more capable big brake kit. And the GM ATS front brake swap has been done before successfully. In fact, you can buy an adapter kit from S&S Engineering that basically makes the GM 2014 Cadillac ATS front Brembo brakes direct bolt-on. However, the rear brake calipers are a different story. The stock rear calipers and the 2004 Cobra calipers in the rear are insufficient. The brake piston size is too small. I believe it's around 40 or 41 millimeters. The ATS matching rear brake caliper uses a 43 millimeter piston. So I would like to use a 43 millimeter piston in the rear so that I have proper front to rear brake distribution. So I guess you can buy Ford Focus brake calipers for the rear, which have a 43 millimeter piston. I don't know what year offhand, but it's an option. It's an option that also bolts right up. I believe if you're using SN95 rear brake brackets. However, those Ford calipers are known to have issues, frequent failures. So I wanted to go a different route. And the route I chose was to match my front Brembo calipers to the rear calipers used on the Cadillac ATS as well. Now, the problem with that is there is no adapter available on the market, and there is no rear brake bracket available on the market to fit the ATS caliper in the rear. This is a project I'm going to do myself. It's a learning experience, and I want to bring you along with me. So this is how I designed this. This is the original brake bracket here. And this brake bracket would mount like that. Now you can see it's a little off, the two holes, and it needs to be about right here. So I need to make these ears bigger. So what I did is traced it true to size to some engineering paper and made the ears a little bigger with a notch to clear the caliper piston, and that should mount that right about there. So I sent this drawing and this part to be 3D scanned and put into CAD, gave it to some guys at a metal fabrication shop, and printed this plastic piece. Now this is just a prototype, to see if it fits, and also you see it doesn't have any holes. This will need to be installed. I'm going to then put the caliper in place as well, mark these holes, and then that's where it'll be drilled and this will be mounted. Or it will tell us if there's any revisions that need to be made to this design. Let's see if it works. Well, that didn't work. Where the caliper was mounted was too far outboard, which is going to require me to move the bracket inboard about 4 millimeters. So I hit the bench to do some modifications to this bracket. This is the finished modified bracket, and now it's ready to see if the caliper fits in the proper position. Okay, it's bolted in place now. Let's take a look and see how it fits. As you can see, the caliper is centered over the rotor now, which was my intent. One last thing, and that is to check the fitment of the wheel and make sure it doesn't hit the brake caliper. Oh, well, there's obviously no issue there. Now is the difficult part, which is finding someone who can scan this and then print it and cut it for me out of metal. I say that because the fab shop I was originally working with, I decided was not a good fit. So that meant back to the drawing board for me, and I decided to do it myself. I had to download a 3D scanning software as well as CAD software, and now I wanted to do it for free, so that was the conundrum. Where I started was finding a 3D scanning software. So I downloaded Polycam, which is a 3D scanning software for your iPhone, and then I downloaded Autodesk or Fusion 360, which is a free CAD software to anyone for non-commercial use. After 3D scanning my modified plastic brake bracket with Polycam, I was able to load that file into Autodesk. Once loaded in Autodesk, I was able to recreate the brake bracket in the 3D software. The obvious next step is to send it to a company to have them print it in plastic as a prototype to test fit it on the car. It has finally arrived. I got so excited, I started ripping this apart, and then I stopped and said, no, I want to bring you guys along with me on this. So this is the part I designed. And there it is. Now is the real test to see if what I designed actually fits the car. So I am really anxious about this because this is my design, and not only is this my design and my first ever design, but it's a design of someone else's design. So there could have been discrepancies in their design, and then I modified that and 3D scanned that and then created this design. So no issues thus far. Just slide this back in. Got my caliper. Where's the rotor? I need the rotor first. Okay, so the bolt spacing for the caliper on the bracket is, I think, just the tiniest bit too close together. I need to widen that ever so slightly. I got a little more light here now, and I see that it is not out far enough. So there's about 3 millimeters on that side, and there is about 10 millimeters on this side. So that's a difference of 7. Split it by 3.5 and move it 3.5 millimeters this way. So here is my current design. After installing it, I found I just need to widen these ever so slightly. I decided that this offset here needs to be moved in that direction about 3.5 millimeters, so really there'll only be about 1/2 millimeter of an offset. And then I also found that these holes were not properly positioned, so I marked those. Back to the drawing board. So here we have my third, or actually my second, but this is the third bracket I have attempted to fit on this car with my GM Cadillac ATS rear brakes. Hopefully this one works. This one had a roughly 4 millimeter offset, and I built that into the design thinking I needed it. I don't know what happened, but it turns out I don't need it. Or do I? This is the ultimate test of this bracket for this brake caliper. So I moved this back out 3.5 millimeters, but let's see, I got 7 on that side, and I got 10 on this side. So it moved in the right direction, but too far. So 7 and 10 is a difference of 3 millimeters. I should move it back 1.5 millimeters. My only concern is that I could either do it by making the bracket thinner by 1.5 millimeters, but we're going from steel to aluminum, so I would prefer it to be thicker because aluminum isn't quite as strong as steel, but it's much, much lighter. But my question now is there any difference in the scale, in true to life scale here, what I'm measuring here, and the scale of the part that I have in CAD? I think on my drawing, I'm gonna take 1 millimeter off the overall thickness of the part and call it good and print it in metal.